equation is defined as a polynomial on one side and it being equal to 0 on the other side. And in order to solve it, we need to satisfy the terms of the equation. In other words, find a variable which, when plugged in, leads us to whatever it is we have, in this case, 0. And by the way, the term root and solution begin to get used interchangeably for these types of equations. Roots and solutions are numbers that make the equation correct, okay? I know the word root seems weird, but it's going to get used more and more. Make the equation correct. In the gray box right below the jibber jabber on the top of the page there, the zero product property is explained to us. And I want to really quickly share with you what that means. Real quick, refocus that. Zero product, and this is in the gray box. First, make the polynomial equal 0. So the polynomial goes on one side, 0 on the other. Second, factor the polynomial if it's not already. And I'll show you what I mean. And solve by setting each factor, this all sounds confusing, but it'll get clarified, I promise, equal to 0. Okay, I'm going to do this out of order a little bit because I feel like it's important that you see it from its beginnings. So I'm going to start with example 2. Okay, here's example 2. And the book example is there as well for you. Okay, here we go. T squared equals negative 7t minus 6. T squared equals negative 7t minus 6. If you are asked to solve this equation, step 1 is to make all of that equal to 0. And by the way, I recommend keep the quadratic a positive. What does that mean? I'm going to show you. Keep the quadratic a positive. The t squared is the quadratic. Whatever is squared is the quadratic. And by keeping it positive, it's always easier to factor. Now there's two ways to get this equal to 0. Either subtract t squared from both sides, or add these two components to both sides. Based on this recommendation, I'm going to add these two components. Okay? So I am, in effect, by doing this, making the polynomial equal to 0. This side is now 0. This side, the left side, is now t squared plus 7t plus 6. Factors of 6 that have a sum of 7. How about 1 and 6? Okay. Step 2 is factor it if it's not already factored. T plus 1. And if you're struggling at all with factoring, you need to slam on the brakes and get this under control, because the rest of the year is going to use factoring. Forever. That's it. There's no more time when you're not going to factor. So if you're struggling at all with factoring, you got to nail it. Foil it to check to make sure that you've factored it correctly. I'm not going to do that right now, but I highly recommend that you do it. Foil to check, because otherwise, if your factors are wrong, then your solutions are going to be wrong. Now, I need you to recognize what this means. What I have just done is made it equal to 0 and factored it, right? That means either this and or this have to equal 0, right? In order for two factors to equal 0 when multiplied, one of them or both have to be 0, right? So either t plus 1 equals 0 or t plus 6 equals 0. Otherwise, if neither of these equals 0, then their product, when you multiply this times this, will not equal 0, and I'm automatically wrong. We're on step 3. Solve by setting each factor to 0. T plus 1 is the first factor, equals 0. T plus 6 is the second factor, which also equals 0. Can we solve for t in both of these? Subtract 1, t is negative 1. Subtract 6, t is negative 6. That means that the answer to this question can be negative 6 or negative 1. And you can plug that in right now if you want. We'll plug in the negative 6 right here. Negative 6 squared, so if that's what t is, then it must equal negative 7 multiplied by negative 6 minus 6. So if I square negative 6, I have a positive 36. Remember, the entire value of t is negative 6. 36 is equal to 7 times 6 is 42 minus 6. Is that true? Yeah. So you know your negative 6 checks out. We can do our negative 1 as well, just so that you see how it looks. Negative 1 squared is equal to negative 7 multiplied by negative 1 minus 6. 1 is equal to 7 minus 6? Yes. So I call this zeroing out. We zeroed out the polynomial. We factored it and we foiled to check. Wink, wink. We set each factor equal to 0 and solved. Finally, I plugged in what I suspected were my solutions to the original polynomial equation and verified that my solutions were correct. Now, the reason I started with example 2 is because example 1 starts you here. In example 1, it's already factored for you. And I didn't want you to get confused when they basically brought you into the game at step 2. So let's look at what one of those might look like, and they're a lot easier when they are already factored for you, but that's not the norm. So I'm going to go ahead and flip the page. And now we're going to do example 1, keeping in mind that the same 3 steps exist. And if it's already factored, like this one, you have less work to do. Okay, this is not a normal looking binomial, right? Whatever this was originally, 2q squared plus 6q was what it originally was. The only thing you could factor out, well, you could have actually pulled the 2 out. I don't know why they didn't pull the 2 out. But anyways, this is how they've factored it for us. So we've already gotten to the place where we're factored. The next step is to set each factor equal to 0 and solve. So that means q equals 0. How convenient. And the other one, 2q plus 6 equals 0. So the solution set is 0 because it's already solved. This factor we set equal to 0. The second factor we've set equal to 0. 0 is going to be the first one. The second one, subtract 6. Divide by q. 0 and -3 appear to be our solutions. Stay with me, folks. Let's test it in the original factored equation. They gave us this. I wrote that just so that you could see it, but they gave us this. Let's test 0. 0 multiplied by 2 times 0 plus 6 equals 0. 0 times 6 equals 0. Is that true? Yep. -3. Let's go to -3 and plug it into the q values. -3 multiplied by 2 times -3 plus 6. -3. Does that equal 0? These two zero each other out. -6, +6. So our answers are correct. Okay? Now you might also be given a factored version that looks normal. Like, here's another example one. X plus 4, couple of binomials, x minus 3 equals 0. It's already factored for you. Okay, it's already zeroed out and factored, which is why I wanted you to see from the beginning that if you're given to it this way, you do have to do all the steps. Zero it out, which is what we did here. Factor it, FOIL to verify you're correctly factored. Set each factor equal to 0 and solve. If we start right here, we've already eliminated zeroing out and factoring it, steps 1 and 2. Okay? So if I've already here, I'm already zeroed out and factored. So set each factor equal to 0. So x looks like it can be -4 and 3. If I plug in -4 here and here, I create a 0. 0 times -7 is 0, right? If I plug in a 3 here and here, this zeroes out, meaning this times 7 is 0. Here's one that's a little more complex, and that's example 3. (3x cubed) is equal to 4x 2x minus 1. Okay. What they don't share with you, the book doesn't share with you, is you're going to want to multiply and simplify as much as possible first. So that's going to give me 3x cubed being equal to 8x squared minus 4x. Right? So far, so good? Okay, now I'm going to go back into my steps. Zero it out. In other words, make the polynomial equal to 0. Keep the largest degree positive. Remember how I said keep the quadratic positive? Well, really, keep the largest degree positive. So to do that, I'm going to subtract and add accordingly. 3x cubed minus 8x squared plus 4x is equal to 0. Okay, let's factor, my friends. Is there a greatest common factor that can be pulled out? X. X goes, leaving you with 3x squared minus 8x plus 4. Keep factoring. Factors of 12x, factors of 12 that have a sum of negative 8. Say again? Negative 6, negative 2 will give us a positive 12 and a negative 8. Very good. He says negative 6 and negative 2 are our units that we'll use in the middle. He's right. I'm going to keep factoring. That's why I said you have got to factor. The 6 I'm going to place next to the x squared. And the 2 I'm going to place by the 4. That shouldn't be a square. Sorry about that. And by the way, do not forget about this x. This x was factored out. It will re-enter the picture here shortly. Pull out your 3x, x minus 2, negative 2, x minus 2. Okay? Which means the factors are x times 3x minus 2 times x minus 2. The factors are x times 3x minus 2 times x minus 2. And again, the product of all those things is 0 because we zeroed it out. So instead of solving 2 factors for 0, how am I going to solve this time? How many am I going to have this time? 3. Yep. The first one requires no thinking at all. The second one, 3x minus 2 is 0. So x is what, 2/3? Trying to go quick. Not sure I'm going to get to binders today. I'm going to try. And the last one is 2. Okay, where all of this can crash and burn, though, is if you didn't factor right. And on your homework, you're going to see I wrote FOIL to check. FOIL to check. Because some of you in your factoring did not factor stuff correct. So if that happens in this, you're going to automatically be wrong. I mean, unless there's some luck involved. That's it. 1 through 27 odd.